Hey everyone, and welcome back to our Learn to Code with Swift Playground series. Made it this far, we are now graduating to Learn to Code 2. In this new set of puzzles, we're going to be introducing some seriously powerful concepts and starting off with variables. Think of variables as labeled containers that store information your code can use and change. Whether that's keeping track of score, names, or even colors, variables make your program smarter and way more dynamic. Let's go ahead and go through the quick introduction, and then we'll delve into some puzzles. So when we think about all the names on our phone, numbers we can store on our contacts list, there's far more than we can remember. Coders store this information in containers called variables. Like a contact in your list, a variable doesn't change its information unless we change it ourselves. To create a new variable, we use the keyword var, V-A-R, followed by a name for the new variable, then a value. So for the new contact, var, so variable name equals Mia. Then we have another variable of age, which we've then set to be 19. The name stores a string, which is represented by these, characters within the quotation mark. And then the age is an integer. This is a whole number. Whole number means it doesn't have a decimal point. So this is exactly 19, not 19.5. With assignment operators, we can set new values for a variable. So maybe, Chris has, had their birthday a couple times, and we can update those numbers. So here, age equals 18, then we've changed it to be 19 manually. If we want to add 1 to the age, this would take whatever it is currently. So it would grab that newest number of 19, add 1 to be 20, and then we could also use multiplication, division, any mathematics, and in this case, we've times it by 2. After we create a variable of the type, the information it stores never changes. So since we've set the variable of age to be 18, if we were trying to change it to be a string value, it would say, hey, nope, you've set this to be an integer. I cannot change this to be a string. But we can update it to be another integer, so the other number being 21. Alrighty, let's get started with keeping track. We have our good friend Hopper here. I think they are the poster child of Learn to Code number 2. So what we need to do is declare a variable. So in this case, we're going to set up a variable for the gem counter. We're then going to collect said gem, and then we're going to increase the counter. So we are given the variable gem counter, and we need to give it a value. Well, starting off, and we can even see in the top left, our gem counters don't natively have a value. We can assign this to be a number. So in this case, we're going to do 0. We're going to move to the gem. We're already pros at our commands. So we're going to go ahead and do 2 move forwards, double check, 1, 2, yep. We're then going to collect the gem. Now, if we want to update the variable, we have a couple different options. We can take the value of the variable and we can set it to be something, or we can add a number to the variable. In this case, let's go ahead and just manually set the value of the gem counter to 1 like it's asking. We're going to reference our variable. Notice when we're referencing it, just like with functions, we only have to use that keyword once when we're declaring it. So var gem counter, just like how we did function, func, collect gem, and then when we call upon it, we just reference the name. We're then going to use the equal sign after a space, add another space, and set the value to now equal 1. Let's go ahead and run through our code. So we're going to move forward a couple times. We're then going to collect the gem, and then we're going to update our counter to be 1. So we've declared our first variable. Using this variable, we can now track the number of gems. And this playground is 1, but maybe down the line, we're going to collect, 10, 20, 30 gems, and we need to keep track of that number. All right, bump up the value. So we've created a variable and changed its value, and we're now going to practice this skill by correctly setting the value of the variable as we collect individual gems. So once again, we're given the gem counter, and we are starting off with 0 gems. So there's 5 gems that we do need to collect. So I think all we need to do is every time we collect the gem, we need to increase that counter by 1. Okay, so let's go ahead and just look at the logic initially. So we're going to need to move forward. We'll then want to do our collect gem. And then every time we collect the gem, since it's not built into the collect gem function, we're going to take our gem counter and we're going to give it an additional gem. Now, in the last playground, I may have mentioned that there's a couple different ways to do this. So the first way that we did last time was we set the value to equal a static number. So 1, if we collect the next gem, we would repeat this logic and then do 2. There's another way to do this. We could do this by referencing the variable. So we can have the gem counter equal the gem counter. So in this case, it would basically say, okay, what is the current value of this? It's 0. So this would be 0 equals 0. Well, that doesn't really help us. But then we can use plus 1. Now, next time we reference the gem counter, it's going to have the value of 1. So if we were to move forward again, select the next gem, and then repeat our logic, we even copy and paste if we want to save some time. It's going to go ahead and say, okay, the gem counter now equals, this would be 1, and then we're going to take 1 plus 1. So that would be 2. So if we take our logic and we repeat this for a total of 5 times, we have 1, 2, 3, 4, 5, we're going to be able to increment that counter by 1 each time. This is also a great tool because as we go through, I don't want to have to say this equals, 0 plus 1 or 1 plus 1 or 2, right? This allows us to cheat the system a little bit by referencing the variable and just having it increment by 1 every single time. There's also a even shorter method of doing this, and I'll show you that in the next playground. There's lots of different tools that once you understand the concepts, you can learn little shortcuts in order to make sure that things are faster and maybe even easier to read. And whatever's best for you, you can use that option. So we're collecting all 5 of the gems, and we've incremented the counter every single time by 1, without having to remember what our gem count was each step along the way. So incrementing the value. I went a little bit ahead of myself. And you can see here, it is suggesting we use this new method. So instead, I'm going to show you an even faster method for this one. So here we have our gem values again. We need to start it off by 0. We have no gems to start with. We're going to go ahead and complete the puzzle. And when we do complete the puzzle, I'm going to show you the shorthand version. And again, feel free to use whatever version you like. So this is actually going to create a random number of gems every time we run it. So we need to be able to handle, any scenario that it throws at us. We'll also need to be able to efficiently move through this program. So let's really quickly also think of an algorithm. So we're going to have to move forward. We can use our is blocked because we don't know where the gems are always going to be. So let's go ahead and do a while, and we're going to do the is blocked, but we're going to use the exclamation point in front of it for the inverse. So while we're not blocked, then let's create a nested while loop. So while is not blocked again. Then check if we're on the gem. So if is on gem. In the cases that we are on the gem, well, of course we're going to collect that gem. But now I'm going to show you the shortcut. So if we take our gem counter, we can use the plus equals space 1. So this is the shorthand version of referencing the variable, having it equal the variable plus 1. It's basically going to say, okay, I'm going to look at this value and I'm going to add 1 to this value. Again, we explored this example that it's asking us to use. So you can use either method if you prefer the one that it's suggesting in this playground that we did last time, this one. Both of them accomplish the same goal, they're just a little bit shorter. Okay, so when we're not on the gem, we definitely need to move forward. And in the case of where we are blocked, so not in the nested while loop, we're going to go ahead and turn right. This is going to make us go forward. We're then going to be blocked. We'll turn right, move forward again, be blocked because we can't fall off the edge, and then turn right. Okay, let's go ahead and step through our code. We're going to get a new fresh set of gems, and we should be good to go. It is nice that we get to use our algorithm, our while loop skills in these other playgrounds. So as we go through, we're going to collect the gem, and we're going to increase the counter by 1. It's kind of funny that I also got ahead of myself, but this is how I do prefer to increment the variables. So my brain's like, get there quickly. Again, that's my preference. But this method, or the my number equals my number plus 1, work the exact same way. It's just whatever way you prefer to write or read the code. Because again, whenever we have puzzles where it might be giving us a random set of gems and random number of gems, we can't always reliably know how much or what number we're going to. That's why it's really important to be able to, just like with the algorithms, handle those different scenarios. It looks like we are good to go. Because when we get to the end, we're going to be blocked, and we'll be like, okay, we'll turn right, but then we're still going to be blocked, so it should hop us right out of this loop. So we'll be like, oh, we're blocked. Okay, let's turn right. Oh, we're blocked. Okay, so we have to hop out of that whole loop. Awesome. So by combining the conditional code, loops, variables, we're creating the foundations for some pretty complex apps and ideas. In seeking 7 gems, we have another challenge. We're going to be, keeping track of the value and the variables, and we can actually use our logical operators to look at those values and make decisions based off of them. So in this new puzzle, we're going to be collecting exactly 7 gems. The gems appear not only in random locations, but also at random times. So I think what we're going to have to do is maybe ping pong between these 2 locations, and as we move through back and forth through the playground, it's going to be respawning these gems. Okay, so we need to create a system that's going to run a set of commands while our gems are less than 7. And we can see here that we can use the comparison operator. And we do have an example here. So let's go ahead and implement this example. We need to first declare a variable of gem counter. And we're going to have it equals 0. We're then going to use our while loop and say while gem counter is less than 7. Make sure there's spaces in between these. We'll add our brace. So we want to repeat this logic until the gem counter is no longer less than 7. So when we reach 7, it should stop. Okay, so let's create this logic and this algorithm to repeat the process. So if we're on a gem, let's go ahead and collect the gem and make sure that we're incrementing the gem counter. We can do our gem counter, do the plus equals 1, or the equals gem counter plus 1, whichever one you prefer. Then we're going to determine if we're blocked, because we're going to be going back and forth, like I said, ping-ponging between this wall here and I guess the lack of wall over here. So if is blocked, we're going to be not using the inverse. We're going to be checking if we are blocked. We'll then turn around. So we could do 2 turn lefts or turn right. Both would work. And while we're not looking at either of those if statements, we're just going to be going ahead and moving forward. So this is essentially our, as I keep calling it, ping pong logic. And when the counter is 7, we should exit this loop. Let's go ahead and step through our code and make sure that it works. Okay, so we have a gem in front of us. So we're going to be running this because, again, our variable is currently 0. Now it's 1, 2, and you can count this as you go. You can also look at the tracker in the top left. We're going to be kind of going back and forth, and it is nice that the gems kind of randomly respawn, but we know our logic is working so far. So let's go ahead and speed this up a little bit, and we can kind of just see every time we collect the gem, we're at 6. Okay, now we're approaching 7. We're at 7, and then there we go. And the nice thing is too, you'll notice that even when we went to another gem, we didn't collect it because we had 7. We had exactly 7 gems. We're like, no more. I don't need to collect any other gems. I am satisfied with my number of 7. Okay, 3 gems, 4 switches. Well, I have a feeling that we're going to be using some logic we used from last time, but maybe we're going to introduce a new variable because we now need to collect exactly 3 gems and toggle open exactly 4 switches. And we have lots of gems, lots of switches. So I think we're going to be using those comparisons in order to make sure that we are, collecting the exact number and toggling the exact number that's specified. So let's go ahead and create our variables first. We'll create our gem counter again. I'll have it be 0 by default. And let's also set a variable of switch counter. I like how in the example, use a descriptive name like number of cats. We'll do switch counter since we have gem counter. If you want to call it toggle counter or whatever you want, as long as it's descriptive and makes sense to you. So let's think about our while loop for a second. We're going to be repeating the conditions until, I guess, those different numbers are satisfied. So we can do this in a number of ways. I think I'm going to use the opposite modifier again. I love using the opposite modifier. So while our gem counter is, we can either do the less than, or we can do the not equal to operator. Both would work. So I'm going to go ahead and say not equal to 3. So we do that by the exclamation point equals 3. Now, as a word of warning, every time after an equal sign, I suggest hitting the spacebar. Otherwise, you will get some weird errors. Okay, what is the other condition that we're counting for? Well, we could use and, but that's going to allow us to collect more gems, right? If we're going to say while gem counter is, not equal to 3 and switches are not equal to 4, we're actually going to end up running into some issues. So instead, let's use the or symbol. So while gem counter is not equal to 3, or while switch counter, again, you can use the whatever operator you like, but I'm going to use the exclamation point equals again 4. So while the gem counter is not 3, or while the switch counter is not 4, what do we want to have happen? This is where we can handle our algorithm and our logic. We can say if the gem counter is not equal to 3, and we're on a gem, this is when we can say, hey, go ahead and collect that, right? Because we don't have the desired amount of gems, and we're on the gem, why not collect it? And remember from last time, we also need to increment that. Make sure we're incrementing the gem counter for collecting gems. We'll use that plus equals space 1. Okay, let's handle the condition of if we're on the switch. We can use our else if here. So else if switch counter, we're going to use our logic again, does not equal 4, and we're on that close switched, is on closed switch. Our brace here. We'll then want to toggle the switch and then take our switch counter plus equals 1. We're going to increment that by 1 as well. Okay, so this is our logic. The only thing we now need to handle is, because we do have some twists and some turns and some blockage within our program, we do need to make sure that we're handling the cases of when we're blocked. So still within this massive while loop, let's go ahead and handle the case of when we're blocked. So if is blocked, we'll go ahead and I think we just turn right. Yes, because we'll go through the teleporter. Yeah, so it looks like we just need to turn right here. We can always adjust it if we're wrong. And then in every other case, we'll definitely want to move forward. Okay, well, let's go ahead and step through our code and see how our logic works. Again, it should basically say, okay, while these conditions, both of them aren't true, we're going to go ahead and, collect only 3 gems. Once we're done collecting the gems, we're not collecting them anymore. Our variable's high enough, we don't have to worry about them. Same thing with the toggles. And then anytime we're blocked, we're going to turn right. Oh, you know what? Okay, I think I might have messed that one up already. This is definitely not a right turn. I did say if it was wrong, we could change it, right? Yeah, because we're going to try to go into the water pad here, and then we're going to turn around. Oops. Okay, let's go ahead and see what happens, because he'll probably turn. Okay, we got ourselves an infinite loop here. Okay, let's go ahead and fix our algorithm. So in the case that we're blocked, and then we're blocked again, so we turned right and then we were there, let's go ahead and turn around. So within the if statement, if we're blocked again, let's go ahead and turn around. We'll do a double turn left. Okay, that should fix it. Okay, our program's going to restart. We have some new gems. Let's make sure our is blocked turns around. It's funny, this is why you test your program, because when I visualized it, I was like, oh yeah, you only need to turn right. But then, you know, on the second turn, it's like, oh, actually, that doesn't work. We'll get stuck in an infinite loop. So that's why we always test things, and we can make those adjustments. Again, part of coding is that problem solving and, you know, the reiterative process. Okay, so here's where we're blocked. We're blocked again. So we're going to turn left twice. Okay, that's giving us the course correction. There we go. Okay, so we're now collecting our third gem. So coming up on the other gems, we should just be skipping them. So let's see what happens when we move to that next gem. Okay, if on gem and it is not 3, we're not on switch, so we're skipping it, right? Our logic is dictating that whenever we have 3 gems and we're on a gem, if we have less than, you know, not equal 3, we'll collect it. Otherwise, we're 3, we're satisfied, we don't need to collect it anymore. So we know that works. I'm going to speed it up a little bit, because we're repeating the same logic for the switches. So we toggle that one, we're happy with it, 2, 3, 4, and then we're done. We don't need to toggle the last one. We wanted exactly 3 gems and 4 switches, and we've succeeded in that. Not only that, we were keeping track of 2 separate variables, our gems and our switches. So you can see how the power of variables can be really powerful, whether that's my score, your score, team A, team B. We can track those different variables and adjust them as we see fit. Okay, the checking for equal values, we're going to be checking to see if something equals something else. So where we've been adding the variable numbers, we can actually use the comparison tools that we've been using for equals, less than, greater than, etc. to compare 2 different variables. So here we have the switch counter, which is going to equal the number of switches. It also wants us to declare our gem tracker again on step 1. So var gem counter, have this equals 0 to start off. And we're going to be collecting gems until it's the same number of the amount of switches on the map. So we'll use our while again. Gem counter is less than switch counter. So again, we're grabbing this real quick before we keep coding. I want to point out that we're using the let instead of var. This is called a constant. With constants, we declare the value once and then don't change it ever again. With variables, we're expecting to change, or what we call mutate, that value. So a good example of a constant would be the year you're born. You're not going to be changing the time and place that you were born, but your age is something that's always updating. Even every second of every day, you're growing older. Okay, back to our coding. So while our gem counter is less than our switch counter, let's go ahead and collect those gems. So if is on gem again. We'll go ahead and collect the gem. We also need to remember to increment the counter by 1. So our gem counter plus equals 1. And we need to handle the case of when we're blocked again, because as we go forward here, we can see that there's a little bit of water before the bridge. We'll need to turn our character. So if is blocked, we're going to go ahead and turn right. Otherwise, we'll go ahead and just move forward through this puzzle. Now, unless I make a mistake like last time again, where we need to do some course correction, we should be good to go. So let's go ahead and run our code. So this time we have a total of 4 switches on the stage. Also go ahead and do the step through so we can watch it in real time. So we're only going to be collecting gems until we hit the maximum of 4. So we've collected number 3. And number 4 is coming up. So after this, we should be good to go. We might turn right and move forward, but then we'll stop. We no longer need to collect more gems because we've satisfied the number, which is equal to the number of switches. So if we were to run this playground again, Oh, we got 4 again. Okay, I'm gonna run it until we get a different number. Okay, this time there's 8. So in this scenario, we're going to run until we collect 8 different gems. So here we're at 5, 6, 7, and then finally 8. And then we're all done. So you can use this if you have, a number of tries, and you can track the amount of attempts, right? Comparing the variable to a constant is a very important skill. Okay, we have a challenge here, round up the switches. So we're going to, oh yeah, here, now it's talking about the plus equals is faster. I already told you that. We cheated, we took a few extra shortcuts for the shorthand. We're going to use the knowledge of variables, assignment, and comparison operators to create a solution for this puzzle. So we're going to be using the compound assignment operator to add a value to a variable, assign the new value at the same time. Toggle the same number of switches on the second platform as the number of gems. Oh, okay, so this is really similar to the playground we just did before. So let's create our 2 variables. Let's have our gem counter. And then let's have a switch counter. We'll set both of these to be 0. I assume it's going to be random every single time. And we'll create our while loop. So while we're not on a closed switch, because we'll probably go through, we'll collect the number of gems, and then we'll go through the teleporter, right? We're going to do like a little loop here, go through the teleporter, and then we're going to be going ahead and closing those other switches. We'll also need a while is not blocked. Oh, I made a mistake here. I did the autofill, and then I had like 2 is's. Okay, while is not on close switch, while is not blocked. There we go. We'll say if we're on gem, we'll go ahead and collect it, and then we'll add 1 to our gem counter. Again, all things we've done before. We'll then move forward, and then turn right. Okay, so that's our simple algorithm to kind of solve this first puzzle. And then, after we go through the teleporter, we need a way to determine that we need to continue, toggling those switches. And remember, we need to make this and the amount of switches that we toggle equal to the number of gems. So while switch counter is less than gem counter. And then what is our logic? Well, we can repeat what we've done before. While is not blocked, at a brace, we can toggle those switches. Now, before we just handle it exactly like the way we've been handling gems, let's add a extra failsafe to make sure that we're keeping track of the switch numbers. We know when we call these while loops, we might still move forward and toggle another switch, and that's not what we want. So we're going to create a really specific if statement. So if is on close switch, and if the switch counter is still less than gem counter. We're almost creating a failsafe here. That's like, okay, we're going through this while loop, but if I move from a switch to another switch, it might be like, oh yeah, by the way, you need to toggle this. This is adding that extra layer of security to be like, and check for this condition to make sure we don't go over by 1 on accident. Go ahead and toggle the switch, and we'll take our switch counter, and we'll have it plus equals 1. Then we'll be wanting to move forward, and again, going through that square pattern, we're going to be needing to turn right whenever we are blocked. So in theory, the way this algorithm should work is, while we're not on a closed switch, we're going to be going through and collecting these gems. And then we'll be like, okay, so while the switch counter is less than the gem counter, we're going to be toggling those switch. And we even added a failsafe to make sure it's only toggling, again, while the switch counter is less than the gem counter, and this should allow us to have an equal number of gems collected and an equal number of switches toggled. Let's go ahead and give this a go. Okay, so we have a total of 3 gems this time. So we're going to be going through this puzzle. Hopper's going to collect those 3 gems, and then we should only toggle 3 switches. Okay, so we're on the gem. Oh, now we are, sorry. We're on the gem. So we're going to collect the gem. Plus equal 1, the variable moves up. We're going to move forward. Okay, we're not blocked. We're not on a gem. Okay, so now we're on the gem again. Collect it. Variable goes up by 1. So far, so good for our algorithm for collecting. Now, let's make sure after we go through the teleporter, our comparison algorithm is correct. Okay, so moving forward, going through the portal. We're going to move forward. So we exit that while loop because we're now finally on the close switch. All right, now we're doing the comparison. And now we're on number 3. We've added 1 to it. We're going to move forward. Our if statement is no longer true. Our while loop is no longer true, so we're now getting out of it. So that's why I wanted to add that extra condition to check for on the if. You'll notice we moved to this extra switch in the middle and we didn't toggle it because we checked our if statement and we said, nope, you know, we're on the close switch, absolutely, but our switch counter is actually now equal to the gem counter. They're both 3. I no longer need to toggle these. We're able to move out of it. We moved forward. We turned right. We checked our while loop again, and we're like, we're satisfied. We're done running the program. One more challenge here for the variables. We are doing collect the total. So for this challenge, we're given a constant total gems, which is randomly generated from 1 to 12. Using this constant, we're going to write code to collect the number of gems defined in total gems, stopping after that total number is reached. Oh, we got this. We've got this. So let's create a variable to track the amount of gems. We'll do our gem counter again. Set it to be 0. If I could type. And let's use our while. So while gem counter. And we can either do the, does not equal the total gems, or we can use our less than. It's up to you, whatever you prefer. I'm going to do the less than total gems because that's what we did last time. We'll handle if we're on gem. So if is on gem, collect gem. Again, very common repeated concepts here. Plus equals 1. Cool. All right, we need to, I assume, go around in this loop here. Looks like we'll get to the end of the row, turn right, go through the teleporter, and we kind of have this like broken off but usable infinite loop, I hope. We can think this through. Okay, so if, while still within this while loop, if is blocked, we're going to need to turn right. Now, if you remember from that one time, if we get blocked again, we need to turn around. So if is blocked, within this if statement, so we have an if within an if, we're going to need to turn around. We'll do 2 turn lefts. Now, I also get the feeling that because we're going through these teleporters, we might need an extra step of course correction. In the case that we turn left twice and it's still not working, if is blocked, one more time, we'll turn left again. Okay, we have a lot of nested if statements, but at the very end, so outside all of these if statements, but still within the while loop, we need to handle one more thing, which is to move forward. Okay, so this should allow us to grab the random number. We random to 1. Well, that was the easiest challenge of my life. Okay, but this doesn't show off our coding. That's pretty funny. I'm talking about all the if blocks. Let's run through it again. 5. Okay, this should have us go through the teleporter. Yeah, that's funny. Wow. Well, we know our program works if it only requires 1, but I definitely want to see what happens when we're blocked and we're going through those teleporters. Because the number was 10. I mean, it does say random number generated between 1 and 10. Okay, so at this point, we're going to be collecting our 3rd gem. We need to keep going. Let's see, so we're blocked. We'll then turn right. We'll go forward. We'll come out this side. Yeah, this is where I was thinking about the blocking being a little bit goofy. Okay, so we're gonna get blocked. We're gonna turn right, and then we're gonna turn left twice. Okay, that corrects it. Okay, and we'll collect the 5th one, and then we should be good to go. But if we had a higher number here, our logic should handle us turning absolutely around, going back through the teleporter. These nested if loops are kind of my fail-safe, my foolproof way to have our friend go through the coding puzzle. Other than that, we completed variables. So by using comparison, by tracking variables, changing the values, we're able to solve all these puzzles. This is really great for tracking scores or any information that might be used within your apps or programs. So great job. The next topic that we'll be tackling, drumroll please, is types. We got a little bit of a sneak preview with types when we're talking about these strings and integers, on how, if we declare this gem counter to be an integer or a whole number, we can't have it equal a string, even if I put 0 here, right? We're going to get an error because now when we're doing these additions and comparisons, it's trying to compare a string value, aka text, to a number value. So when we deal with types, we'll be learning all about those different types that we can use in programming. So thanks so much for watching. We'll see you next time. Dream big, code bigger, and have a great day.